All right, we are 10-6, applications of vectors in plane. I said skip example 1, skip example 2. Here is the deal. Ready? We have, just as a recap, okay, we had complex form. Write this at the top of your paper. We had complex form. We had rectangular form. Do you remember what they call it? Rectangular form. They call it, what did you say? They call it, component form. They call it component form. Okay? Rectangular form or component form, and then we have polar form. Polar form. Okay? All right, here is complex form. It is A plus BI. Rectangular form or component form is just A comma B. And polar form is R cosine theta plus I sine of theta. Okay, here is what's going to happen in this section. Are you ready? What they're going to do is they're going to say you have a soccer ball that is being kicked at 10 meters per second at a 45-degree angle. So we're going to put it into polar form. The wind then is blowing at 5 meters per second at 210 degrees. No, not 210 degrees. 120 degrees. Okay, so how is the wind blowing this ball? How is the wind blowing this? Back toward me, right? The ball is getting kicked this way and the wind is blowing back this direction, right? Okay, so, I mean, the ball probably will still go forward, but not as fast, right? Because the wind is blowing back, okay? So here's what's going to happen. They're going to say, where is the ball going to end up? So what we do is we take each one of these and we write two separate polar forms. We convert it to component form, and then we add those two component forms together, right? And then that will tell us where the result is going to be. Got it? Okay, so let's go down to, I don't know, example 3. They're just wanting us to write it in component form. Find the component form of the vector that represents the velocity of an airplane. It is going 60 miles per hour at a 7-degree angle with the horizontal. That is just giving you all of the polar form bits, right? So R cosine theta plus I sine theta. Okay, what is R? 60. Cosine of 7 degrees plus I sine of 7 degrees, okay? And we're wanting to put it in component form, so we're wanting this guy right here. How do I go from this to that? How do I go from polar to the other? Yep, distribute. I take 60 times cosine of 7 radians or degrees.
I'm thinking degrees.
7 is a degree, so we're going to be in degrees. So 60 times cosine of 7, and then 60 times sine of 7. Which one's going to be bigger, the x-coordinate or the y-coordinate? X is going to be way big. Y is going to be like really tiny, right? So this guy is going to be a big number. This guy's probably going to be a small number. 60 cosine of 7. Somebody have it? 59.5. 59.5, that sounds about right. And the y-coordinate, what? 7.31. 7.31? Perfect. Okay, there you go. That's component form. We're taking all of the polar form bits, using the polar form to find component form. Got it? Beautiful. Okay. All right. Find the direction angle of each vector. We've already done this before. Should we do one of these? Find the direction angle. Let's go to B. Let's go to B, because this is not in the first quadrant. Negative 10I plus 7J. This is kind of a way of complex form, except this is in like circuits. Have you guys ever done like impedance and whatever? What is it called? In like circuits, like electrical circuits, like you have an I and a J. No, you know what I'm talking about? No. Okay, whatever. So this is kind of like negative 10 comma 7 in component form. Instead of just like writing with whatever, they write it as I's and J's, and it's like amplitude and whatever of the impedance of the electrical circuit. They just write it with an I and a J in there. Whatever. Negative 10 comma 7. What quadrant are we in? Second. Negative 10, 7. Right there. Negative 10 is this guy, 7 is this guy, and we have an angle theta, and they want us to find the direction angle. Okay, how do I find this angle theta? 7 is opposite. 10 is adjacent. So we are doing tangent of theta equals, opposite is 7, adjacent is negative 10. So we do inverse tangent of 7 over 10. And what do you get? 34.9? Is it 35.0? Rounds to 35.0? 35.0. Okay, if you tell me 35 degrees, I'm going to think it's in the first quadrant. So I have to do this. How do I find that angle? 180 minus 35, which is 145 degrees. There we go. That is the direction angle. Not so bad. Okay. All right, here we go. Now we're going to talk about resultant force. This is the all for the big money right here. These are the hard questions, okay? So we have something is happening like they're pulling out a tree stump, right? Okay? And like we chained around like a tree or whatever for pulling like the root out of the ground, right? So we have a truck and a chain, and one truck is pulling this way and another truck is pulling this way. Why do we use two trucks? 2 reasons. More power, but also, if I have one truck that is pulling this tree stump out and it comes out of the ground, where's it going to go? Like, it's going to run into the truck and I'm going to probably have a shattered windshield, right? Okay, so we pull 2 different directions so that resultant is going to go in between, right? Or you're just pulling with such force that it just launches it, right? Like over top of you? No? Okay, whatever. Okay, I don't know what you said. What did you say?
Why are you pulling it from the front?
What? What do you mean pulling it from the front?
Go ahead.
No, I'm talking about like my back shattered windshield.
That's not a windshield.
That is not a windshield.
What? Like in a truck?
Windshield.
What is it called in the back?
Rear window.
Oh my God, whatever. Whatever. Anyway, okay, so yes, pulling out of the ground. All right, we have one force. Here we go. The first truck and the second truck. We're going to write polar form of the first truck, second truck. First truck is 150-pound force. So polar form is 150, parentheses. Cosine of, what's the angle? 20 degrees. Plus I times sine of what? 20 again, right? Okay, that's my first one. Let's do component form of him. What's 150 times cosine of 20? 141. Okay, point something. 141. Okay, cool. What's 150 sine of 20? 150 times sine of 20. 51.3. Okay, so that's the component form of the first vector. All right, second vector. Second truck that is pulling at 100 pounds of force, so a little less, at a 70-degree angle. So we've got cosine of 70, 70, plus I sine of 70. Okay, all right, let's find component form of him. 100 cosine 70. 34.2. Okay, comma. 100 sine 70. 94.0. Okay. Oh, component form. All right, now what? Add those two vectors together, right? We did vector addition yesterday. Okay. 141 plus 34.2 is 175.2. Check that. Yes, okay. Next, 51.3 plus 94 is 145.3. Check that. Cool. All right, now, that's not what they're wanting. They are wanting to find the magnitude and the direction of the resultant force. Okay, so this is my resultant force. Here we go. Now we've got to work backwards, and my resultant force is going to go 175 this way, so 175.2 this way, and up 145.3 this way, right? So what's the magnitude going to be? The length of this, the Pythagorean theorem, right? Okay, so 175.2 squared plus 145.2 squared, and then the square root of that number. That's my magnitude. What do you get? 227.6. And that is in, are we in meters per second? Pounds. 227.6 pounds of force. It's going to come out of the ground, whatever we're pulling, like the tree or whatever it is. 227.6 pounds of force. At what angle? How do I find that angle? Tangent of theta is 145.3 over 175.2. So I do inverse tangent of that thing. And what's the angle that it's going to come out of the ground at? What? 39.7 degrees. Do we need to add it, subtract it from anything? No, we're in the first quadrant. So it is going to come out of the ground at 227.6 pounds of force at a 39.7 degree angle. Does that make sense? That's what we're asking for. Find the magnitude, direction of the resultant force. So two polar forms, convert to component form, add them together, and then convert back to like the basically polar form where you have your angle and your resultant force. Got it? Okay, let's skip example 6. Let's go to example... I don't want to do example 7 either. Let's go to one of your homework problems because we're going to talk about the lost goose. Where is my lost goose? A very lost goose on number 12. I want to talk about our lost goose here. This is funny. All right, we have a bunch of vectors going on at the same time for this very lost goose, but this is actually not a bad problem. A very lost goose is flying 30 kilometers north, straight north. If I write component form for a straight north kilometer, 30 kilometers, what would that be in component form? 30 kilometers straight north. What would that be in component form? 0, 30, right? I'm going 0 in the x direction, 30 in the y direction. Does that make sense? 30 degrees straight north, or 30 kilometers straight north. Then I'm going 50 kilometers east, and east is this way, so I'm going 50, right? What would that be in component form? 50, 0, right? Okay. East is going to be positive, west is going to be negative, south is going to be negative. Do you see how this works, right? Then we're going 70 kilometers south, so I'm going to go like 70 this way, right? What would that in component form be? 0, negative 70. Okay, how do I figure out where he's going to end up? What? Add them all up. So if I add all 3 of those vectors together, what will that be? 50, negative 40, right? Okay. All right, now we're in component form. Now, where is the goose now relative to starting position? He's going to be like in the 3rd quadrant or 4th quadrant in comparison to where he started from, right? Okay, so we got to figure out where he's going to end up. I'm going to plot that point. 50, negative 40 is like here. 50, negative 40. All right, I want to know how far he is from where he started, because that's start right here, and what direction or what angle he is. Okay, so how do I figure out how far he is? That would be like magnitude.
A squared, B squared.
A squared, B squared, C squared. So 50 squared plus 40 squared, and then the square root of that. How many kilometers? How many kilometers is he? 64 point what? 0.3? 03. Well, we'll go 64.0. 64 kilometers. And let's figure out the angle. Okay, so here's my angle. Opposite is 40, adjacent is 50. So tangent of theta is 40 over 50. Or you could just do 4/5 because that's what it reduces to. Inverse tangent of 4/5, that angle theta is how much? 37.8. 37.8. Do I need to add, subtract, do whatever?
Subtract.
Oh, yeah.
That.
38.7.
What?
38.7.
38.7. Okay. 38.7. Now I want to know what this is. So 360 minus the 38.7 degrees, and you get something. 321.3, and that is degrees. So I am 321.3 degrees at 64 kilometers from where I began. 64 kilometers at 321 degrees from where I began. Make sense? That's where my goose is ending up. Now, some of these are just asking, like, what is the final velocity? That just means find the magnitude, and you don't have to find the direction, right? This one is asking for what is the balloon's resultant velocity? You're just finding the magnitude and not finding the direction as well, right? So you just have to do your Pythagorean theorem at the end. What is the plane's resultant velocity? Just find the magnitude. 13, which way and how far? 13, you have to find both magnitude and direction. Make sense? Oh, you're awesome. Thank you. Thank you. Thank you. Okay. All right. How about that? Good?
All of them?
Blah, blah, blah. Yeah. Yeah. Do all of them.
What the heck?
Sorry. You don't really know what's going on, number one? Number one is saying the magnitude is 5 and the direction is 60. So in polar form, this would be 5 cosine of 60 plus I sine of 60. Now, how do I go to component form? Yep. Now I just distribute. Okay. Good? And number 4, 5, and 6 is saying take those and put them into polar form, basically.
I think so.
Okay, so you're going from one to the other. Got it? Beautiful. Any other questions? That was really, really super fast, but you've got like a long time. You've got like a half an hour left. Beautiful? Good.